I want to make science, but which is driven by reality and the industry. So
Mm-hmm.
I want to make science, but uh, at the end of the day, I need funding to pursue my academic research, and also everyone wants to see its work uh, being applied in the real life and industry. So, for example, right now in my internship, I talk with engineers in the factory. So there is often misunderstanding between like research and development engineers and production engineers.
Mm.
So research and development engineers, they are trying to like find a new formula and some new ideas, but they are not aware of the like production sides. So they
Mm-hmm.
always fight each other. So
Yeah, yeah, yeah.
whenever in the factory, whenever R&D department suggests something, so our production engineers say that how can I transfer that chemical? How can I
Mhm.
like buy it, transfer it, and how can I operate within my current like setup, like process flow. So because of that, like eh, yesterday we were talking about it, and one of the engineers told me that you know what, I'm right now a production engineering in this factory, but my long-term goal is to pursue PhD, then
Mm.
move forward to industry, come back to industry again. That is a really great idea. I really appreciate it. So maybe the next question would be like, when you look at the whole world, battery, like from the battery research perspective and industry, so how do you see the like part of like the part of the world, like for example, as I see, like in Nordic side of the Europe, they are really good at science, like fundamental science, like trying to find new materials, chemicals, but they don't look like in industry part. So like when you compare the continents and like main battery regions, what would be your comment for each? Like, for which profile do you recommend that place? Because like most of our followers and most of our team members right now, me as well, we are trying to find a place to pursue our battery research and career. According to our needs and aim, the direction should be different, right? So what would be your comment on that?
So, okay. Now, what I know of is there are two kinds of things you'd have heard. Like there is a research institute, like a RISE. Okay. So when I was working in Japan, I was in a research institute. Okay, Japan Advanced Institute of Science and Technology. So those kind of places are generally, as much as I know, okay, like this is not again like foolproof kind of a thing that you can talk to more people about it. But then from my experience, those kind of places do applied research. So in my lab, like my previous lab, it was more about studying very new materials, like I showed you, and developing new materials. So that was like the main focus. But in universities like Uppsala University and things, it's more like doing a fundamental study. Okay. This is like universities try to do this. I'm not very like 100% kind of like confident on this statement which I've heard. Okay, but then somehow I do, I mean, like from a research institute, I've come to a university. I do see that kind of a research because if you look into the recent papers that have been published, for example, in different universities, if you take for that matter, that have been studying more in detail about something which is established. Okay. So there may be like papers on why PA is a bad binder at 2%, but is a very good binder at a 10% or something like that. Okay. But then a research institute will not care about PAA. It doesn't, for them, it is about making a new binder material which works very nicely at 2%. Getting the whole the whole thing right. So, and that binder may not be industrially straight up today. It may not be applicable, or in future it can never be applicable. In my previous lab, we also have like few patents, but then it's like when you go into industrial scale, okay, it becomes difficult. But then we also have a patent from our previous lab, which the industry was very interested in when it came to like making additives. So that can happen. So but then research institutes try to make a tomorrow kind of a thing, while universities do study something like current materials in depth. Because even optimizing the current materials in depth can result in a great thing, right? Like if you optimize a PA is already commercialized. So if you optimize at 7% rather than at an 8% or a 6%, okay, so currently suppose you are using 10, but you can optimize it at 7% somehow. Okay. So you are adding that much higher capacity to your battery because you're adding more active material. So I think it depends what is your objective. How do you want to see your research? Okay. Do you want to make new materials? That is fun. Okay. Do you want to study more materials? So it doesn't matter. I mean, like it's optimized, it's not. I didn't study like 80% what happens, 60% what happens with my polymer, 50% what happens, 90% what happens. I just wanted to study at 80% this new material, how it behaves, what is the charge transfer, okay, and if there is any charge transfer, so not put, but like I had done a monomer kind of a reaction, small reaction to prove the charge transfer that is taking place, okay, pi star transition. So simple like reactions and new materials. It depends what is like your aim. How do you want to look at your research? Do you want to look at, so yeah, I mean, like industry, end of the day, if you want to transition, it'll anyway help you. Okay, you are working with anodes irrespective of in academia or in I mean like more industrial focused. So it doesn't matter. Also try to look for, I would say, if you want to industrial PhDs, if you want to go into industry, that is very important. Uh, because industrial PhD, you will be working closely in association with industry, so you will be knowing what you are looking into, like what the industry is looking into rather. So those are again very good options, I would say.